welcome back. Let's look at this build your understanding problem. Okay, so we're investigating the possibility that the proportion of proportion of patients taking Lipitor that experience these flu-like side effects is greater than 0.019. The null hypothesis then is the statement that the proportion is actually equal to whatever it was, the proportion taking the competing drugs. Okay, anyway, same as the alternate hypothesis except with an equals in there. So a sample's obtained and a point estimate's computed from it. 19 of the 863 patients sampled reported flu-like side effects. Run that through a calculator and you get 0.22. So we're going to be asking ourselves, is it likely or unlikely that we would have gotten a proportion of 0.022 from a sample if in fact the population proportion is 0.019? Is there sufficient evidence to conclude that to accept this or reject it, the null hypothesis? Okay, but before we get into that, let's verify that we can use this method of hypothesis testing. In other words, that we can treat p hat as a normal distribution. So we're going to have to make some assumptions here. We're going to assume random sampling was used in the clinical trial. That's probably a reasonable assumption. They're probably using good practices. Again, in this class, we're not going to have enough information to know for sure, so we're going to have to make some assumptions. We can at least compute that this number works out to be greater than or equal to 10, as it needs to be. So let's see. The number of people in the sample is 863. P is, we are assuming P is, for the population, is 0.019, and then 1 minus 0.019. So if you run that through a calculator, you should get 16.08. That's greater than or equal to 10 as we need. So that's the second condition verified. And 863 is probably, so again, we're kind of doing some assuming here. 863 is probably less than 5% of, let's just say, number of Lipitor patients. Okay, so therefore, we can, oh, by the way, these three dots in math mean therefore. So therefore, we can proceed with confidence that p hat is at least approximately normal. Okay, so we can use our normal distribution to get probabilities for p hat. Okay, so that's just verifying that we can use this method. Here's the actual hypothesis test. Oh, let's see. I need to know the mean. So the mean is going to be the same as p, which again we're assuming is 0.019. We're going to need the standard deviation also. The reason we need those is so that we can convert to z values. Let's see, what is the standard deviation? It's the square root of p times 1 minus p over the sample size, 863. And when I did that on a calculator, I got 0.0046. Okay, so here comes the hypothesis test. The p-value, the probability that p is greater than 0.019, converting that to a z. I'm looking then for the probability that z is greater than 0.019 sorry, this was supposed to be this is supposed to, okay, this is supposed to be the sample, the point estimate. Sorry about that, 0.022. Okay, so converting that to a z then, we have 0.022 minus the mean for p hat, which is 0.019, divided by the standard deviation for p hat, 0.0046. Okay, so that works out to be what does that work out to be? 0.65. Okay, and look that up on the table. P greater than, or sorry, z greater than 0.65. Oh, so let's just remind ourselves about the tables, how they work. Again, we're doing a right-tailed test here because we're looking for greater than, so there's our 0, here's our 0.65. I want to know the probability, and this is my z distribution, I want to know that the probability that z is greater than 0.65. Okay, so I want that area. But remember, the z table gives you areas to the left. So you could use 0.65 as your z and do 1 minus the area it gives you, because 1 minus that area would be this one. What I'm going to do, though, is I'm actually going to go over, I'm going to use symmetry of the distribution. I'm going to go over to 0.65, negative 0.65, and I'm going to get the answer from the table, and then that answer from the table will be the same as the area there. Okay, so negative 0.65 on the table, 0.65, that looks like 0.2578. Okay, that's our p-value, the probability of getting a sample proportion that's as far off the mean as this far or further. That's greater than our level of significance, because we were told this time to use level of significance 0.01. So that means that our probability is not so small as to be unlikely. Okay, when the probability is so small that it's less than your level of significance, that's when you say it's unlikely that the null hypothesis was actually true. If the p-value is greater, you're going to not reject H naught. So not rejecting H naught means we're going to conclude there's sufficient evidence to support, or there's not sufficient evidence to support H1. Okay, so for me it helps to make a chart here to decide what I'm going to write. So do not reject H naught. Does that, if we're not rejecting H naught, then we must not have sufficient evidence to support H1. Okay, we're keeping H naught, therefore we're not keeping H1. But remember, your conclusion is always going to be stated in terms of H1. So I'm going to have to say not enough evidence to support H1. Okay, so conclusion, there is not sufficient evidence. Now that we're using levels of significance, we can specify what we mean by not sufficient. So let's get that in there. Let's say at the alpha equals 0.01 level of significance. Now, if you don't know what the level of significance that was used is, you don't know exactly what sufficient means. So to conclude that more than 1.9% of Lipitor users experience flu-like side effects. So having the proportion be more than 1.9%, that was our alternative hypothesis, and we did not find support for the alternative hypothesis. Okay, I hope that one went well for you. That's probably a good stopping point. We're going to keep working on this, so we'll come back and do at least one more example and build your understanding for this section. So I'll see you in the next video then to look at that.